Hello, my name is Savannah Clark and I'm in Chemistry 119, Section 621, and today I'll be showing you how to draw a Lewis structure for carbon tetrachloride. First, you want to count the total number of valence electrons in the compound. So for carbon, we have only one carbon in the compound, so we'll multiply the number of valence electrons for carbon, which is 4, by 1. And the total number of valence electrons for carbon is 4. Now for chlorine, there's 4 atoms. So what we will do is we'll times the number of atoms times the amount of valence electrons for chlorine, which is 7, to get a total number of 28 valence electrons. So then we need to find the total number of valence electrons. So what we'll do is we'll simply just add these together and we'll get 32 valence electrons. So now I like to determine the number of pairs because it makes it easier. So what you're going to do is basically you're just going to take the total number of valence electrons and divide it by 2. 32 divided by 2 is 16 pairs. Next, we need to determine the central atom, and to do this, the central atom is typically the element that has the lowest number subscript because it can form more bonds with the element with the higher number subscript, but also if they do have the same subscript, it's the least electronegative atom or element that will go in the middle. Since carbon has a subscript of 1, carbon will be the central atom. Next, we can go on to draw the Lewis structure, and as mentioned above, carbon is the central atom with 4 chlorines surrounding it. Now, to connect these, we need to use bonds. So, a bond is considered a pair, so we will need 4 bonds to connect carbon and chlorine. Now with this, we can scratch out that we use 4 pairs, so we have 12 pairs left. With this, we need to ensure that each atom follows the octet rule, so what we want to do is we want to fill the octet for all atoms and see what is left over. So as I'm drawing these lone pairs, we can count that each chlorine atom gained 3 lone pairs. So that means 12 pairs were used. So now we have 0 pairs left. Now we need to check if all atoms, satisfy the octet rule. So for carbon, we have 8 valence electrons because each pair or each bond is equal to 2 electrons. So that's good. And for the chlorines, we have 3 sets of lone pairs and 1 bond, which is equal to 8. So they're all correct. And that is how you draw a Lewis structure for carbon tetrachloride.